Hi everyone, it's Shreyang from Department of Chemical Engineering, IIT Kanpur. So, in today's discussion, we will be going to start thermodynamics. So, that is the thermodynamics of physics. So, as the name suggests, thermodynamics is thermo and dynamics. So, thermo means heat, and dynamics is something is in motion. So, in the more formal way, what we are going to discuss here is the laws governing the conversion of heat from one form of energy to another form of energy. So, thermodynamics deals with the concept of heat and its conversion from one form of energy to another form. So, basically in this chapter what we will be going to discuss is the laws governing the conversion of thermal energy. So, we shall study the processes in which work is converted into heat, and at the same way work like the work is converted into the heat can also convert it into the work. So, vice versa. So, in a cold weather, in a winter season, when we rub our hand, so rubbing of our hand is the work is done by us, and that is converting it. So, the heat is generated by rubbing of our hand. So, here the work gets converted into the heat. Okay, so that is one of the example of conversion of energy. So, in physics, we need to define the notion of heat, temperature, work, carefully. It takes a long way to arrive at the correct concept of heat. Heat first in the older years, it is described in the form of a caloric fluid, where so it is described so when we have a caloric fluid, so we are having some fluid here, and let us say it is hot and the environment is cold. So, there is some molecules come to the colder environment due to the temperature gradient. So that is so the correct, so it is the caloric fluid. Okay, so this is something similar when we have a pipe of a fluid, something like this. You have a fluid here and it is flowing due to the pressure difference. So this is comes out from the similar concept. So the flow of heat, according to this concept, the flow of heat continues till it reaches to the same caloric level. So this picture of heat is disregarded. Now the question is why this is disregarded. So according to this concept, if you think if you see there is a drill, so if you see there is a drill and the work is done, so here is some drill, so and some drilling work is going on to drill this hole here, and this is done by rotating this string in a way. So according to this picture, the caloric concept, which kind of drill we are using will tell us the amount of heat generated. If it is pointed, then it should generate more heat according to the caloric concept of heat. But in more general sense, in the more correct way, heat is the work that is done by the external work that is converted into the heat. It does not depend upon how this drill is employed or which kind of drill is employed. It is the work that is converted into the heat. So how much amount of work is done, that should be converted into the heat with some amount of unuseful work that is destroyed in some sense. So this is the thing. So according to the caloric concept, so according to caloric concept, heat was regarded as the fine invisible fluid filling in the pores of a substance on contact between a hot body and a cold body. The fluid flows from the colder to the hotter body. Okay, so this is the caloric picture of heat. So what I described earlier is, like I am again explaining. So here is a fluid So it is filled in a pores, some pores, and when it comes in contact with hot environment and it is cooled, then fluid flows from cold to hot environment. So now we have discussed the correct way to describe the heat is that it depends the amount of heat generated correctly the amount of heat generated depends upon the amount of work done. So that is all about the fundamental concept of heat. So now let's come back to the thermodynamics. So thermodynamics is essentially describes the macroscopic picture. Macroscopic means to say that which you can easily see by your naked eyes, but if you compare it with molecular picture, so you cannot see the molecules around you. Whatever you see around you is the macroscopic picture of whatever it is. So thermodynamics tells us about, only gives the macroscopic picture. So in formal way I can write thermodynamics is a branch of physics that deals with the concept of heat and temperature, and so the interconversion of heat and other forms of. So this is the same definition as I introduced in the introduction. Another point is thermodynamics is a macroscopic science. It deals with the bulk systems and not the microscopic. Microscopic means at atomic level, at electron, and then at electron, that is quantum level, and then so on. So we are not dealing with this macroscopic system, we are dealing with the macroscopic science. So that has to be taken care of, and the concept of thermodynamics come much earlier, before the concept of microsystems. So the question is when we will be going to learn what is happening at the molecular level. So later, after this chapter, we will be having a kinetic theory of gases, where we will be going to learn about the molecular picture of the gas, of the molecules inside the gas. So we will be having a velocity of the molecules inside the gas, and that has some energy. So we will be going to discuss that in the kinetic theory of gases. So that will give the molecular picture of the atoms and the molecules. Now we now we are here discussing the thermodynamics. So we need to discuss what is the difference between the mechanics and thermodynamics. So I can explain this with one example. So you are having a wooden some target here, let's say some target. So here we have some target, and bullet has to be fired. So bullet has to be fired from here. Some color we can take. So this bullet, and this is a wooden board, let's say wooden board. So this, when you fire the bullet, this bullet will go and hit this target and embed in this. Here we will be going to discuss the difference between the mechanics and thermodynamics, and so in the next lecture we will continue it.